right. So, uh, before we go over the circuit, which the answers were up, so hopefully those of you who really gave it a legit effort and needed to check out the answers, that helped you some. I will answer any questions you have on it. But before we do that, um, we were planning on having a quiz on that orange sheet this week. I talked to you about that last week. I'd never put it on my webpage, but we did talk about a quiz on that first thoughts sheet. I'm going to put that on hold because it was originally planned for this Wednesday, Thursday. And I will see y'all, assuming we come to school Wednesday, I will see y'all Wednesday. But then if they decide after Wednesday not to have school Thursday, then I won't see the other class. And we are having block schedule, if that's your question. Yeah, they told us that this morning. So we're going to continue with block scheduling. So I don't want to run the risk of y'all taking the quiz and then them not taking it. And it's not the kind of quiz you can take at home because it'd be too easy to cheat. So what we'll do is we'll just wait until we get some clarity on the potential virtual shutdown thing, um, and we'll just kind of but keep in mind that we will have a quiz on that coming up at some point. What I may do, here's what I'll do. Okay, quiz is going to be Friday if we have school Friday, so we'll do it Friday. That way, if we're here, I'll see all classes. If we're not here, then nobody will take it. You don't like that idea? You like my first idea better of just oh yeah, that's a when do they do y'all know when they publish the COVID cases, the weekly COVID cases? So that'll be when we go back to masks. We're definitely going back to masks. At least. Uh I don't know that. Okay, I said we're definitely going back to masks. I don't know that. I'm assuming that we're going to be well over the 1% minimum that we need. Because I think we're pushing like 45% right now. That's an exaggeration. That's called hyperbole. It's, it's a literary element. Yeah. Um, while we were having a meeting with the admins during first period, Miss Marino, the front desk lady, came in and said that we have 10 unfilled teachers absent tomorrow, which is rare for a midday. Like it's not uncommon on Fridays because teachers just like to not come on Fridays. Um, but in the middle of the week, it's really rare. So I think it's probably going to happen sooner than later, but that's 100% speculation. They haven't told me anything to make me think that other than just my observations. Uh, yeah, there's 20 out today. I know that because when I called Marino to tell her I wasn't coming today, she said, "Okay, well we have 20 not coming," and I was like, "Okay, well let me see what I can do." So I ended up coming. Yeah, and they're a smaller high school than we. Anyway, uh, so we will hold off on that. If we do go virtual, actually, I'm going to sit down today and try to think about what my plan is going to be, and if we're here tomorrow, we'll spend the beginning of the day talking about what virtual is going to look like. I do know, and I can tell y'all this now, that if we go virtual, we will be taking attendance. It's not going to be like if you can remember 2 years ago there was no attendance taken. We'll be taking attendance, but in order to be marked present, all you have to do is the assignments. You don't have to actually log into a Google Meet or anything like that. If you turn in your work, that's considered present. If you don't turn in your work, then that's considered absent. And it is in absence like usual. So if you don't turn in your work, you then have to find a way to get it excused and stuff like that. So it will factor into exemption if you have any non-AP classes. So just something to keep in mind. We are posting attendance, but as long as you do what you're supposed to do, then you don't have to physically log into any meetings or anything like that. Uh, the reason we're going to do block schedules this week, because I mentioned that they were considering doing 7 periods every day, is on virtual days. If we do go virtual, we're going to continue running a regular schedule, and you'll have your second, fourth, sixth period on Wednesday, 1, 3, 5, 7 on Thursday for the virtual days also. So we're just going to continue the block scheduling when we're virtual, um, and the plan is that there will be no scheduled Google Meets per period. So basically, it's going to be. Do y'all remember 2 years ago the way it worked? So basically, the teachers, we are instructed to have everything online, videos, lessons, whatever, posted and available by 8:30, and then you just have whatever. You use your time how you need to that day to get those assignments done. You don't have to actually log into first period or log into second period or anything like that. There's too many other variables at play. You may have younger brothers and sisters you've got to take care of and help and stuff like that. So just make sure you get your work done. I don't know. I think I almost want to wait until I have a more clear picture. But y'all have any questions about all of this that I might could answer based on what they told me this morning? No? Okay, cool. Have y'all done the warm-up? Is it coming okay? No? What? Have y'all? I did spend a lot of time talking and taking your attention away from math, but have y'all had a chance to put forth your best effort on it? Maybe not. Okay, we'll do this one together. So the warm up today is, where's my pen? There he is. It was 0 to 2. I remember that. The numerator, I think, is x minus 2, and the denominator was x squared. It was x minus 3? Okay. X squared minus 6x minus 15 or plus? Minus what? 7? Oh, okay. All right. The denominator does factor, and I guess it wouldn't be a bad idea to see if it'll factor in case something cancels. But the denominator factors to x plus 1, x minus 7, and nothing cancels. We are going to learn a technique later in the year where if the denominator factors, you can do that partial fraction decomposition where you do the a over stuff and b over stuff, and you solve for a and b and all that mess. But I wouldn't do that because every single time, actually, I mean, wait, did anybody see the trick to this one to get the antiderivative? No? Okay. When you have a fraction, I always tell you to think about one thing first. If it's not recognition, this is not recognition. So if I see a fraction, I'm doing the antiderivative, the very first thing I think about is if I let u be the denominator, is the derivative of that in the numerator? Is 2x minus 6 in the numerator? And if not, can I make it happen? So that it's an x minus 3, it's not a 2x minus 6. Can I turn that into a 2x minus 6? Yep. All I have to do is double it. So if I put a 2 up here and I double the numerator, I have made the top the derivative of the bottom. I need to put a 1/2 out here. And if the top is the derivative of the bottom, then what's your antiderivative going to be? It's the natural log of the bottom. Natural log of x squared minus 6x minus 7. And then we'll evaluate that from 0 to 2 because those are values of x. And that stuff that I wrote in green would have been in my head. I probably would not have actually written that down. If it helps you process it and think it, then write it down. But I never did actually change my variable to u, so I can still use the 0 and the 2. And now it's just a matter of plugging in and subtracting. Good. Every time you have a fraction, if it's not something you immediately recognize, for example, this is a fraction, but I hope you don't try to do u substitution with that one. The one I just wrote over there on the right side, what is that antiderivative? That took too long. Inverse tangent, that's recognition. You should be able to spit those out immediately. You need to be able to spit those out immediately because that's not something you want to waste your time thinking about. That should be a quick gimme, and then you can use your thinking time for the more challenging problems. You've got to polish up those trig and inverse trig derivatives. So if it's a fraction, first consider recognition. Is it something you immediately recognize? If not, then I will see if the top is the derivative of the bottom. Because that's also fairly quick if you can make that recognition. And then if it's not that, now we need to think about more difficult substitution methods. Okay. Let's finish this. I'm going to ignore the 1/2. And I'll plug in my 2. That'll be the natural log of 2 squared is 4, minus 6 times 2 is 12, minus 7, that's negative 8 minus 7 is negative 15. But the absolute value of that would be positive 15. Minus, plug in 0. 0 minus 7 is negative 7. but the absolute value of that is positive 7. How do we feel? If this were multiple choice, what would you do next? Well, look at the options and see if that's there. But what if it's not there? What could they have done to this? And something you need to be prepared for just in case. If you are subtracting natural logs, you can combine that into the quotient of their arguments. Right? That's something you just have to be ready for because they probably would do that in a multiple choice. They would probably do that. And if you saw it in the multiple choice options, it would probably jog your memory. So, oh, yeah, there are these properties. Hopefully, it jogs your memory. And they could even go one step further. Now that we are thinking about log properties, what else could I do? I don't like the word distribute because distribute means you're multiplying across addition or subtraction. Yeah. Although, yeah, so we'll make the 1/2 an exponent. Now, that may be what you were thinking in your head. So I could make this 15/7 to the 1/2 power, which is the square root of 15/7. Right? So just be ready to use those properties. If it's a multiple choice question, they love to play with those log properties. Good? Are we happy people? Yeah. Okay. Let's talk about. Where's my. Oh, I need a new window here. Y'all can just hang. Is it okay if I'll just hang on to that since I just did it for you? We good? Oh, so y'all already still had it turned in. Okay. Let's look at this, and the answers were already up. So, were there any particular problems that you had questions about? Who's not here? Brody, Donald, Allison, and is that it? Yeah. Okay, so questions on the warm up or the circuit. It's been a little over a month, maybe 2 months since I first did it and posted the answers. So I'm a little bit fuzzy on my memory, but I seem to remember as I was doing this that they were not absolutely brutal substitutions. Like there was no like weird double substitution or um, funky properties or identities or anything. Is there any one in particular that you would like me to look at? No? Bottom left? Anything that's exponential is kind of scary. So this one, and did it get it? Yeah. I think a lot of these, I want to, yeah, that's right. A lot of these worked out very nicely, and that you didn't even have to throw in any content. I think a lot of them, the DU was right there ready to go, and you didn't have to actually make any adjustments. So this looks really bad. It's pretty scary. It's not something I immediately recognize, and it's not a power rule. So we're now down into U substitution territory. What do you think you would choose for you? What would you choose for you? Yeah. If you have an ugly exponential, you're going to start by choosing the exponent for the U and see what happens. There may be a case where that doesn't work, but if it's a U substitution problem, that's almost always where you're going to look. So I'm going to let U equal the 5x to the 4th minus 4. And then du, remember du, you're not looking at the problem and finding du yet. Right now, all you're doing is what we've been doing for about 5 months. You're looking at whatever you chose for you, and you're finding the derivative of that thing. So what is the derivative of 5x to the 4th? Good. Whoop, I'm in red. That'll be 20x cubed. And the dx is part of it. I want that to be a habit of yours. I want you to remember that dx is part of that du. So what I'm looking for is 20x cubed times a dx. Do I have a 20x cubed times a dx in here? Yeah, I can rearrange this. I have 20x cubed times e to the stuff times dx. You can rearrange that. And so I see my du. That means I can go on. I can now proceed with my substitution. Let's take out 20x cubed and dx, and we will replace those with the du. And remember, the du needs to be like way over here to the side. You want to give yourself room between squiggle s and the du to put the rest of your function. I still have, I'm going to write this for a hot second and then take it away. I still have e to the 5x minus 4 in there, but I have to get all of my x's out. That's going to be pretty easy because 5x to the 4th minus 4 is my u. So I'll just take that out, and we'll make this e to the u du. And it cleaned up very nicely. A very ugly looking antiderivative on the surface, but if you pick the right thing for u, it kind of falls into place. Hello! And the antiderivative of e to the u would be, good, e to the u. Let's see, so there is the antiderivative. Just please remember not to stop there. We need to plug my u back in. So my answer is e to the 5x to the 4th minus 4 plus c, and we're done. How's life? If you see an ugly exponential function in an antiderivative, it's almost always going to be a u sub, where you let u be the exponent and then just kind of let the pieces fall. Any others? Any others that y'all ran into that were tricky? And again, the answers are right here. By the way, when we do circuits, which I have a few more that we may look at in this antiderivative stuff, I think I mentioned this last time, but it may not be a bad idea at the very beginning before you even start solving them, just to label each block A, B, C, D all the way down. That way, when we're saying, hey, you have a question on one, since they are not sequential numbers, you can say, hey, what about problem L? Can you help me with that one? Makes it a little bit easier for us to navigate and see what we're doing. Good? Cool. So let's see, I can get rid of that. These are 9 problems out of the textbook. These are eventually going to get a little bit tricky. I think the very first one's kind of nice. You probably don't like it because it has trig functions in it. But 41 is not too bad. 44 is, I don't know. But these are trickier ones. I talked to, in one of the videos you're supposed to watch last week, I talked about double substitution and doing u sub, where you may have to do some long division. There's no division in this one, but let's look at some of those more tricky techniques. And then maybe before we get out of here, how much time do we have left? 30 minutes? Maybe before we get out of here, we can, I did my lip. Talk about some inverse trig stuff. So I'm going to leave y'all alone for a minute and see what y'all can do with this, and we'll reconvene in a minute. Remember, when you're doing u sub, what you're looking for is something and its derivative. And remember, the and its derivative part is the important part. So sometimes you have to pick a u that doesn't seem right, but it works because the derivative is what shows up. So we're always looking for something and its derivative. And 41, I need to unfreeze the screen. 41 does that fairly nicely because I see a sine x, and I know the derivative of sine x is cosine x. So I see a u right here. That's my u. And I already see du right here. All of that is du. So what looks a little bit ugly with a bunch of trig in it, after substitution, what you'll have is the square root of u, du, and it's just the power rule. We good? The antiderivative of u to the 1/2 is a power. We'll add 1. 1/2 plus 1 is 3/2. We'll divide by 3/2, which is times 2/3. And I left that blank because I'm going to go ahead and plug my sine x back in. And there's my answer. You okay with that one? I like that one. That one's kind of nice. I think, is it okay with y'all if we, have y'all looked at 44 yet? Have we tried 43? Okay, let's talk 43. Copy. Can I put it on this page? I think I probably could. All right, so 43. Remember, you're looking for something and its derivative. And so I see sines and cosines again, and I know that the derivative of cosine is sine. And there's actually a couple of different ways to do this one. The problem is I do see a cosine, and the sign up here is a problem because that's sine 2x, not sine 1x. I really want that to be a 1x. Right? What all of y'all tried for your u? 2x? Okay. We're just going to see where this goes. It's not going to work out nicely. You can do this. It's just going to create some ugliness. And this is one of the good things. I've said this several times. One of the good things about U sub in the world of integration techniques is it's the best one to just kind of play with and see if it works. The other techniques, whether it's parts or partial fractions or things y'all don't know yet, they're not as friendly to you just to play with. But with U sub, you could try anything. Just when you pick your u, find the derivative of that. What is the derivative of 2x? Good, it will be 2. And so now before I go on, I want to make sure that 2 dx is in the problem. And I can make that happen. I can put a 2 here. I can put a 1/2 out here. Right? So I have made my du show up, which means I can keep going. I'm not going to start over. I can keep trying this. I do know that this 2x can become a u, but I still have an x down here that has to be converted to u's. How could I convert that x to a u? Not that identity. Not there. If if u is 2x, then that means x is the same thing as 1/2 u. And I could put a 1/2 u inside that cosine squared function. I could. That would be correct substitution. But my end result is going to be the antiderivative of sine u over 1 plus cosine squared of 1/2 u. And that's just not that pretty. It didn't make a significant change to the difficulty or the ugliness of the problem. So that is technically correct substitution. It's just not very helpful. And that's why I was saying that's one good thing about U sub is if you want to try something, try it and just see if it gives you something nice. If it doesn't, then we start over, which we will. So what else could I try for U? Okay, let's try 1 plus cosine squared x. What is the derivative of 1 plus cosine squared x? Close. It is a chain rule. We bring the 2 down. 2 times cosine to the first, and the derivative of cosine is negative sine, so you just missed that negative. Okay? And then the dx is part of it. So really, I'm just going to move that negative in front and say negative 2 cosine x sine x dx. Okay, now this is where this problem gets tricky. Do you see a 2 cosine x sine x dx? Not yet. I see a sine 2x, and that, again, that's a problem that I pointed out a minute ago. The different arguments is a huge problem. I would say throughout all of math, even like in pre-cal and algebra 2. If you have a trig function with a 2x and then another trig function with a 1x, whether you're doing antiderivatives or solving equations or graphing or whatever, that makes it very difficult. And there is an identity. It's your double angle identity for sine, and it is one of those identities on the orange sheet. I can replace sine 2x using identities with 2 sine x cosine x. Sine 2x is equal to 2 sine x cosine x. And that's just an identity. That was not calculus. That was not derivatives. That was just something that theoretically you learned and committed to memory in algebra 2, which we know didn't actually happen. Good. And with that change, look, I needed a negative 2 sine x cosine x dx. Actually, cosine sine, but flip it around. I can just put a negative and a negative. And with that negative, I made the top the derivative of the bottom. My u is the denominator, and my numerator is the derivative of the denominator. So the answer is negative natural log 1 plus cosine squared x plus c. Evil, huh? That might be the evilest or sneakiest one of the bunch. Do I need to leave that up there for, whoops. Go back. Do I need to leave that up there for a minute? All right, let's move on. What about, now I do believe 44 is a lot nicer, significantly nicer, and 43. I'm going to give y'all a minute to try 44. Okay, let's talk. How'd this one go? This one falls into place kind of nicely. I think. I don't know. To me, it does. I do think the substitution falls into place nicely. Now, if you can finish it after substituting is a different story. But it's not recognition, and it's not a power rule, so we're in the U sub territory. What did you pick for your U? Okay, we're going to pick cosine x, only the cosine x. And we have the advantage of having just done number 43. And the advantage to that is I already know the derivative of the denominator is 2 sine x cosine x. And I have a sine x, but I don't have an extra cosine, and there's no identity that will allow me to put a cosine up there. So we know the top is not the derivative of the bottom. What is the derivative of cosine x? Negative sine x, and that's what we have. All I need to do is put a negative and a negative. And now I can substitute the sine x dx out. That becomes a du. I have a 1 in the numerator, and the denominator, instead of 1 plus cosine squared x, it's going to be 1 plus u squared. I replace the cosine with a u. And that should be easy. That should be extremely easy. Why is this one so extremely easy? That's your inverse tangent, which I mentioned that just a little bit earlier today. So I'll be negative inverse tangent of u, and u is cosine x. Are we good? So that one it fell in place kind of nicely. But again, it depends. It depends on you starting with the correct u. If you don't pick the right thing for u, then we kind of hit a wall and get discouraged. All right. Now there is another option. Do we have another visitor? There is another option. What if, instead of putting the negative out here, I can take that negative and put it on the inside and make it negative 1 over 1 plus u squared? What is that? That would be the derivative of inverse cotangent. Remember, inverse tangent and inverse cotangent are the same derivative, only inverse cotangent has a negative derivative. So it could be written this way also, and you just need to remember that that's an option just in case they do that in multiple choice. They would probably go inverse tangent instead of cotangent, but they could do this. Yeah? Yeah. Moving back? All right. Let's look at 47. 7. Do you have any thoughts here? You know what? I don't like the dx in the numerator. Is it okay with y'all if I just take that dx and move it over here, put a 1 on top? Just personal preference. There should be something that you see here that jogs a memory or jumps out at you? You know what it is? And it may not because y'all refuse, I shouldn't say refuse. Um, Inverse trig derivatives are usually very, 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 very rusty or shaky or hard to remember. But you've got to know your inverse trig derivatives, and you should know that the derivative of inverse sine x is 1 over root 1 minus x squared. And that should not take that much thought. So in this antiderivative, I see a function, inverse sine x, and I see its derivative. And if you see a function and its derivative, then you've got your u and your du ready to go. This is u, that's du. Now remember that that u is in the denominator, so when you do that substitution, you keep u in the denominator, and this is 1 over u du, which now is nice. Natural log of u. You've got to be very familiar with your memorized derivatives because your ability to recognize those in these antiderivatives is what's going to speed up the process considerably. Yaha. Shiny happy people. See, that looked really bad. That was a really bad looking antiderivative, but it cleaned up fairly quickly. If you know your inverse trig derivative. Moving on. Now, 48, if they weren't already mean, are these mean? Is the snowball getting bigger? Let's look at 48. I really like 48. I think I'm going to pause it. I want you to look at this and just see what you can figure out. Before we do that, let's talk for just a second. Is it power rule? Is that a polynomial? No, clearly not a polynomial. Is it something you recognize? Okay, so rule those out first. Always think for a second. Is it power rule or is it polynomial? I'm sorry, or is it recognition? Or is it the top, the derivative of the bottom? Now, the derivative of the bottom, I need to see a 4, whoops. I would like to see a 4x cubed. I only have a single x. The missing 4 is not a problem. The missing x's, I need 2 more x's. I'm just going to preview what's coming your way. It is possible to fix missing variables, but it is so extremely rare that we have to do that. Assume that's not what we're going to need to do. Try to find a different technique. We'll talk tomorrow about how to fix missing variables. Because we're missing those 2 extra x's, I abandon the natural log recognition, and now we're into more difficult use of. So that's the thought process you want to go through. You want to try power rule, you want to try recognition, maybe try natural log, and if all of those fail, now we get into weirder, more difficult use substitution. So I am now going to be quiet and give you a minute to see if you can pick the right thing for you. Sometimes when you're picking your u, you're not really picking a u. Sometimes you have to look at your problem and see what's available for my du. What do I have sitting there that could be a derivative? And I'm looking at this x to the first. That's x to the first. And I'm looking at that and I'm thinking, this could be du if I could somehow let u equal, and we choose a u that gives me the du that's available. So what does u need to be so that my derivative is x to the first? Well, I would need to start with an x squared. All right. Now, I know the derivative of x squared is 2x, not 1x, but we can fix the missing 2, so that's not a problem. So what if I let u equal x squared? Then my du is 2x dx. I can put my 2 up here. I can put a 1/2, and du is taken care of, and that's the most important part. If you can make du happen, then you're free to go on and try to get this thing to work out. So let's do it. I have my 1/2 on the outside. I'm going to go ahead and take out the 2x dx and replace it with the du. Now, in the denominator, I still have a 1 plus x to the fourth, and I have to somehow get that in terms of u. So if u is x squared, what is x to the fourth? It's u squared. And if you miss this time, I'm going to start throwing things. For the third time today, the antiderivative of 1 over 1 plus u squared is inverse tangent of u, and I'm just going to go ahead and replace my u with an x squared. Very good. So sometimes the du drives the u instead of the other way around. Yes, ma'am? It's not a bad idea. It's worth trying. Can you factor 1 plus x to the fourth? Okay. If it factored, everything else you said is beautiful. If it factored. But the way you check your factoring is expand it back out. So if I multiply this out, that'll be 1 times 1 times x squared times 1, and x squared times x squared. When you FOIL that back out, you have a 2x squared that's not down here. So that's not how it factors. You're thinking about a difference of squares. 1 minus x to the fourth will factor. There is not a factoring for a sum of squares. So it's a good thing to think about. It's just it only works if it does indeed factor. And everything else you said was very, very well thought out and correct. Just that one little form. Cool. Cool. Next. 49. We're definitely not going to finish all these. 49's a fun one. That was beautiful. Everybody give her a hand. That was exactly right. So I'm looking at it, and I go through all of the same thought processes every time. Uh, I don't recognize it. It's not a polynomial. So we're into U sub or something tricky or some other technique. And I like the denominator of 1 plus x squared because I know 1 plus x squared is associated with inverse tangent. So I've kind of got that going in the back of my mind. And if this x was not here, then I would have inverse tangent. Right? Similarly, if the 1 was not there, what would we have? Almost a natural log. I just got to put a 2 and a 1/2, right? So without the 1 or without the x, we have something that's fairly quick. So what we're going to do is we'll just separate this. This is an STD. As long as you keep your denominator in one piece, you can separate addition or subtraction in the numerator, but you can never separate the denominator. You must keep it in one piece. So I'm going to split this into the antiderivative of 1 over 1 plus x squared, which is straight up recognition. Put a dx to kill that one. And then the antiderivative of x over 1 plus x squared, which in my opinion is recognition also, but it does fall under the u sub umbrella. We need a 2, a 1/2, and now we've got nice. What else want the blue? Nice antiderivatives there. Good. Is that nice or ugly? It's one of those that once you see it, you're like, oh, that's not bad. The question is, can you get to that point on your own? Yeah, I don't know. Gonna go back. We might could do one more. Can we do one more? I can never remember how Spain Park time compares to real time. What? Uh, the u for x squared. You're talking about for the second one right here. You could do u equals x squared if you wanted. It would turn into 1/2 1 over 1 plus u. The top is still the derivative. It would work out. But if you have a number, just go ahead and grab the number also, because it's going to zero out with the du. Good. Whoops. I don't know if we have time for these. No! So Spain Park time is 1 minute ahead of real time. Okay. There is a video I want y'all to watch tonight. It's on. It's using inverse trig on I think Friday, whatever day it was. I gave you that orange sheet with all of the template things on it. There were 3 inverse trig templates I said that you absolutely need to know, and this video is going to talk about how to use those 3. So make sure you watch that. I'm not taking today's warm up. I've already given it to you since we went over it in class. So make sure you watch that video, and hopefully I'll see y'all tomorrow.